Good morning, students. Welcome back to another video lesson. Today we shall be discussing another topic from the chapter Human Eye and the Colorful World. And this topic is, as you can see right now on your screen, it is refraction of light by a prism. So the question arises, what is a prism? Prism is a homogeneous transparent refracting medium bounded by at least two non-parallel surfaces inclined at some angle. Now, right now on your screen, you are observing a prism that is very commonly used in the physics laboratory. But let me tell you one thing, that when we use this word prism, it doesn't necessarily refer to a glass prism. Prism might be any transparent refracting medium. Now, the condition is that it is bounded by two non-parallel surfaces inclined at some angle. So when you will be studying in detail about prisms, you would be knowing that in nature too we observe and come across many prisms. Like all of you might have seen a rainbow that is formed after the rainfall, and rainbow is formed basically due to presence of prisms, and obviously they are not glass prisms. So you are having small water droplets suspended in air which act like tiny prisms. Every single water droplet acts like a prism, and those prisms are responsible for creating such a beautiful rainbow. Now, how a rainbow is formed, that we'll be discussing a bit later, but today's video lesson is actually dedicated to study of a very important experiment that is also included in the syllabus of practicals for class 10, and that is to trace the refracted ray, the ray of light that is traveling through a prism. To trace the path of ray of light traveling through a prism, that is going to be the topic of study for today. So as you can see, I've shown the diagram of a prism, and as you can see that I have labeled the different parts of a prism. So right now you're having the different labelings, as you can see. So let me show you. A, D, F, C. As you can see, A, D, F, C. This is the refracting surface. Okay. Similarly, another refracting surface is A, D, E, B. A, D, E, B is another refracting surface. Angle A, this angle, this is the angle of the prism. This is the refracting edge, and this is the base of the prism. So a basic glass prism, or what we commonly use in the physics lab, that is a equilateral prism. So that prism has got a surface somewhat as you can see in the figure. So now let's come to the topic of discussion for the today, that is the experiment to trace the path of rays of light through a glass prism. Let's begin the topic. So now, whenever we are conducting any experiment, the first thing that we should be aware of is what are the materials required for conducting that experiment. So right now on your screen you can see all the materials that will be required to conduct this very simple experiment. What are they? First and foremost, we need a glass prism, obviously. Adding to it, we require a drawing board, a drawing sheet, some drawing pins, some paper pins, a protractor, pencil, and a half-meter scale. These are the basic materials required for conducting this experiment. Now, what we need to do next while conducting any experiment, the next thing, most importantly, that we should be knowing is the procedure. So right now, as you can see, the basic setup, I have tried to through a pictorial representation. Now, right now, as we are all away from the actual setup, we are using several methods for understanding the practicals. So we are making use of several simulators, we are making use of OLabs. So today I have tried to give you a pictorial representation of this particular experiment, and hopefully this will give you a very clear understanding of how this experiment is going to be conducted. So when you are having an actual setup in the laboratory and when you are doing it actually, then it will become pretty much clear to you, and hopefully the knowledge that you will acquire today will help you in conducting this experiment successfully. So as you can see that in the drawing board, the drawing sheet has been fixed with the help of the pins. So in the corners we have to place the pins, and this will help to attach the drawing sheet on this drawing board. In the center we have to draw a straight line, and on this straight line we have to place this prism, keeping the refracting edge of the prism on this straight line. Now next, what we need to do, with the help of a pencil, we have to draw the outline of this prism, the outline of the edge of the prism, and then remove the prism from its position. So once that is done, we will obtain this kind of a setup. Once the outline has been drawn, as I told you that it is an equilateral glass prism, so obviously the outline will be that of a triangle. So this outline has been shown, and now we shall begin with the basic procedure. So next, what we need to do, we have to bring this protector and place it on this line. Next, we have to draw a normal to this refracting edge. So for this, obviously we have to draw a straight line. So this is the normal. Now for the incident ray, we can choose any angle of incidence. Let us choose the first angle of incidence as 35 degree. Now this value is chosen arbitrarily. We have chosen an angle of incidence of 35 degree. So from 90, 35 degree, we have to move 35 degree. So obviously you have to draw the incident ray at this position. So this is going to be the incident ray. Now once the incident ray has been drawn, we have to remove this protector, keep it aside. Now since this is a ray of light, so we have to draw the arrowhead. Now next, we have to place two pins on this incident ray. Remember, the angle of incidence in this case is 35 degree. So let us take up two pins and put these pins on the line of the incident ray. Let us name the incident ray. Let the incident ray be named as AO. So now we have to place these pins on the incident ray at a certain distance. So let the first pin be put like this, and let the second pin be put like this. So we have placed the two pins in front of the refracting edge of this prism. These two pins will be acting as the object, and we have to watch these two pins from the other side of the prism and find out its image. Now, before we proceed to the next setup, let us mark the values. This is the angle of incidence, which is 35 degree. Let us name the prism as P, Q and R. This is the face of the prism, and let us name this line as X dash. So now let us move to the next step. Over here I have tried to show how the pins have been placed. This is another view of the setup. The prism has been kept in that position. Obviously, once the pins have been placed, we have to place the prism on the outline that we have drawn so as to observe its image from the other side. So this is how the prism needs to be placed. This is the line XX dash, the straight line, and the ray that we have drawn. If you remember, we had named this ray as AO. So this is the ray, and this is the angle of incidence, that is 35 degree. This is how both the pins have been placed, and we have to observe its image from the other side of the prism. Let's see how it looks like. Now, when observed from the other side of the prism, these two pins appear somewhat like this. Okay, this is actually the image of both the pins. Now, what we shall be doing next? We have to keep on observing these two images in such a way so that these two pins, rather the image of these two pins, appear to us in the same straight line. Obviously, right now you might be observing the images separately, but we have to observe these two images, the images of these two pins, in such a way that they appear in the same straight line. So once that is obtained, somewhat like this, we have to take two pins more and place them in the same straight line. Let's do that. We can take up this particular pin and place it in the same straight line as that of the image of these two pins. Similarly, take up the second pin and place it in the same straight line as the pins. In this way, the four pins will be aligned in the same straight line. Once the impression has been taken, we have to draw or trace the emergent ray. Let's do that. So now we come back to this particular setup once again. We have removed the prism, and now these two pins, as you can see, are lying in the same straight line as that of the image observed from the other face, that is face QR of the prism. So these two pins are lying in that same line. So once the impression has been created, we will remove these two pins. So let us point out the impressions and remove these two pins from their position, and then draw the refracted ray, rather the ray that is coming out of the prism. So we can call it the emergent ray. So in this manner we can draw the emergent ray. Now let us join the incident ray. We can drop a normal. First of all, let us drop a normal at this point. So this would be the normal, and then we shall draw the refracted ray. So this will be, sorry, refracted ray. So as you can see right now in the diagram that we have drawn the refracted ray, let us mark the arrowheads and name the positions. So let us call it S and this be E. So now as you can see that refraction has took place twice. Let us find out what is the angle of deviation. For this we have to trace the original direction of the incident ray by producing it somewhat up to this point, and then go back by producing the emergent ray somewhat like this. Okay, so the angle that is formed between the direction of the incident ray and the emergent ray, this particular angle is the angle of deviation, and this is denoted by delta. So this is the angle of deviation. So in this manner we can trace the path of the refracted ray through a prism for different angles, somewhat like this. As you can see, in the first case we have drawn it for 35 degree, next for 40 degree, and finally for 45 degree. So in this manner, for different angles of incidence, we can trace the path of refracted ray through a prism, a glass prism. This is how you will be conducting the experiment in your lab. You have to draw these diagrams, and with the help of a very simple setup, you can trace the path of refracted ray and figure out the angle of deviation in each case. Thank you.